Now in this video, we're going to look at the OR logic gate, most specifically making a switch-based version of it. So this is what the schematic symbol looks like. You got a little curved back there, and then it curves up to a point on the top and the bottom. And the truth table there shows that the output is only low if both inputs are low or off. And a switch-based version, it's much easier just to talk about on-off. There you can see these two switches would be off because they're open. The output will be off, which makes sense. You have no path. If we close one of the switches, then we would have a path through the output to turn it on. Or if we close the other switch, we would have a path through the output to turn it on. In this case, we're going to use LEDs. And of course, if you close both of them, same thing. That point will have a direct connection to that point, just in two ways, but it'll be a direct connection, and so it acts just like one connection. So I already have the switches on the board. These are push button switches, so they actually go up and down instead of having a lever like that, but they work exactly the same. You can see here that we got the positive side going to one switch, and then the positive side going to the other switch. We're going to use 5 volts right there. And this is the side of the switch where the two connect. I have a jumper, so these are separated top to bottom. And the top is always connected, and the bottom of the switch is always connected to each other. So we're going to put our load on the right side of the switch. As I said, the top of each switch and the bottom of each switch are always connected together. So connecting something right there is just like connecting it right there. I'm going to take a 220 ohm resistor and I'm going to angle it. It should be a little bit easier to see. Let's put it right there. There we go. So you can see it goes to the switch there, and then we have it over to that row right there. We're going to take the LED, the long lead, the anode goes to the resistor, short lead, the cathode, goes to that gray jumper. So I really assume you know that, but this is for a review. So the LED is off. Both of the switches are off or open. We press that one. Now you can see the LED turns on. So we had a direct connection from the positive supply when we press the switch to that side of the resistor. Other side of the resistor comes to the LED. It's limiting current. We're using 5 volts. Now we have this switch too that we could press if we want to. Has a direct connection to the positive supply when we close it right there. And we can press both of them. Doesn't matter. It's all one connection. So if you're a little confused with that, we can look at the current that is being provided. If we press one, it's about 12 milliamps of current. So this isn't perfectly correct, but it's usually within 1 or 2 milliamps. So it probably is about 12 milliamps. Press that one, again, 12 milliamps. It's the exact same connection. We press both of them, again, we just have a direct connection from the power supply to that side of the resistor, which sets the current. So press one, the other, or all of them, in this case 2 of them, and you have the same outcome. So the output goes high for the most part. It turns the LED on. So hopefully that all made sense. Pretty simple circuit, and so we're going to end it there. Make sure you check out one of the other videos. Click like, subscribe, the bell, and all that. I will see you in the next video.